Now I am going to discuss about spectroscopy. So what do you mean by spectroscopy? So spectroscopy is a branch which deals about the interaction between the electromagnetic radiation and matter. So spectroscopy is a branch which discuss about the interaction between the electromagnetic radiation and matter. This electromagnetic radiation either absorbed, transmitted or emitted by atoms, molecules or any other species. So what do you mean by electromagnetic radiation? So let us see the diagram. So electromagnetic radiation has two components. So one is electrical component and one is magnetic component. So this electrical component is going like this, and magnetic component going like this. This is the electromagnetic radiation, electromagnetic waves. It has two components, one is electrical and one is magnetic, by the speed of light, 3 into 10 power of 8 meter per second. So electromagnetic, what are the electromagnetic radiation? It's ranging from X-rays to the radio waves. Now let's see. So first I wrote UV and visible, for IR, NIR, IR and for IR, micro and radio waves. And these are X-ray and gamma rays. So the wavelength of UV light is 200 to 400 nanometer. For visible is 400 to 800 nanometer. Like that, IR 2.5 micrometer up to for IR 25 micrometer. It's up to go 25 centimeter per radio waves. For X-rays, it takes 1 Armstrong and gamma rays 100 Armstrong. So these are the entire region of electromagnetic radiation. So this UV visible spectroscopy is collectively called electronic spectroscopy, because it is interaction in between the electronic transition of the compounds and UV rays. IR spectroscopy is called vibrational spectroscopy. Vibrational spectroscopy, which is having the information about the vibrations transitions of the molecules. So like that, nuclear, gamma rays are nuclear and X-rays are inner transitions, and these are the entire regions of electromagnetic radiations. So now we are going to see about UV visible spectroscopy. So UV, as I already told, it's a electronic spectroscopy. So now we are going to discuss about basics of UV visible spectroscopy. Basics. So Beer-Lambert's law is the basic principle of UV visible spectroscopy. So what is Beer-Lambert's law? So log I0 by IC equal to epsilon CL. In other words, A is equal to epsilon CL, where A is equal to absorbance, epsilon is equal to molar extinction coefficient, C is equal to concentration of the solution, and L is equal to path length of cuvette. So this is called Beer-Lambert's law, and this is the basics of basic principle of UV visible spectroscopy. A is equal to epsilon Cl. So, what are the electronic transitions possible in their in some compounds? There are 4 important electronic transitions are going into the compound. So, one is sigma to sigma star, n to sigma star, pi to pi star, and n to pi star. These are the 4 important electronic transitions are happen in the compounds. So, sigma to sigma stars is mostly happen in saturated compound. Saturated compounds, it is nothing but single bond CH3, CH3 or methane, like that. Whereas N to sigma star is happen in saturated compound with heteroatoms. So, heteroatoms means apart from C, carbon, hydrogen, nitrogen, oxygen, sulfur is called heteroatoms. So, here the example is CH3N, N is heteroatom. So, next is pi to pi star is mostly happen in unsaturated compounds. So, as you know well, unsaturated compounds is nothing but the compounds having double bond. So, C double bond C, C triple bond C, and so on. The next one is N to pi star. It is happen in unsaturated compounds with heteroatoms. So, C double bond O, C triple bond N. These are the electronic transitions are happen in the compounds. These are the 4 important electronic transitions in their compound. Now, so what are the importance of these electronic transitions? Transition is so our eye mechanism. Our eye mechanism is our eye has lot of pigments are there. See the cis retinal and xanthophylls, and there are lots cones and rods inside available in our eyes. Once the pi to pi star transition is happen in our eyes, that the cis retinal is transformed into transretinal, the photoisomerization takes place. Then only we can able to see, otherwise we can't to see. So, this is the most important process is happened in our eye. That is why our eye is able to see. So, the pi to pi star is most important transition which is happened in our eye. So, next is instrumentation part. Instrumentation, which comprising 5 important parts. The first one is source, and the second monochromator, and sample. Next chamber is sample and reference. Next is detector and recorder. So, these are the 5 important components in UV visible spectrophotometer. The first one is source. The source of light is a mercury lamp or any white lamp. White means white comprising lot of colors. So, the source of light is mercury lamp. The next chamber is monochromator. So, mono means single, chrome means color, which selects the particular light, particular wavelength of light. So, this transfer into light into the next chamber is the light passes through the next chamber is sample chamber, which contains 2 compartments. One is sample and another one is reference. So, sample is we are going to the sample which is going to analyzed, and reference is which solvent we have to dissolve is called a reference. Then the light passes into the detector, which is converts the converts the radiation into signal. The final part is recorded and the output in the form of peaks. The here x axis and y axis, x axis having the wavelength in nanometer unit and y axis is absorbance. Okay. So, this is the typical UV visible absorption spectrum. So, there is 4 important terminologies are there. So, one is if the wavelength is falls on higher wavelength is called bathochromic shift, that is nothing but red shift. If the wavelength falls on lower wavelength is called hypsochromic shift. If the wavelength is higher is called bathochromic, if the wavelength is low is called hypsochromic. If the intensity of the absorbance is high is called hyperchromic shift, whereas if the intensity of the wave absorbance is low is called hypochromic shift. So, these are the basic aspects of UV visible spectroscopy. Next class we are going to see about infrared spectroscopy. So, what is the applications of UV visible spectroscopy? To analyze the lambda max, maximum lambda max of the components and the structural determination of vitamins, to study the rate of reaction and so on. This is the applications of UV visible spectroscopy. So, next class we are going to see about infrared spectroscopy. Thank you.